So as we discussed in the last class, okay, so RTOS is basically time bounded. Okay, so RTOS can be classified into two types. One is hard and soft. In hard RTOS, it is time critical. Okay, so it is not allowed to cross the particular time bound. Okay, so the reliability of that particular hard RTOS should be 100%. You understood? So always that should work. In any failure is will be any failure or interruption or exceeding that particular time bound is considered as a major failure of a system. So I mean that is basically hard RTOS. Say if you observe, say for example in airport, okay, so flight management, maybe it comes under hard RTOS. So that means in a flight coming, going, takeoff, landing, and all these things comes under hard RTOS, because even it is time bounded. You cannot we cannot say 1 minute delay in landing or 1 minute delay in takeoff. All those things are not allowed in hard RTOS. So it is basically time critical RTOS. So second one is soft RTOS. In soft RTOS, some occasional failure is allowed. You understood? Say for example, say you have executed 50 times. Okay, so in out of 50 times, 40, 45 times it was time bounded. Only 5 times it exceeded. Okay, that is fine. Okay, so that kind of application is called soft RTOS. So that is one the difference what you have to understand. So with respect to RTOS. So now, what task we will take up? Say RTOS. Okay. So now I think let us build one RTOS. So let us develop one RTOS. So let us develop one RTOS. So now the thing is what? So when you are developing an RTOS, so you know that resource management will be there. Okay, so resource management, and the second one is, say you are telling memory management. Okay, so you are telling says what are the other things? Interrupt management, resource management, scheduling. Okay, so our task management, you can say our task or service management. Okay, so fourth one is interrupt management. So what is one more management? What we said? Anybody? Shoaib, you said resource management, memory management, scheduling, and
IO,
one
sir.
more. IO, yeah. Input output operations. Okay. Okay. So now you see, let us develop one RTOS. Say for for um, mm, some kind of easily what we can understand, say smart meter. Okay, so for smart meter we want to develop RTOS. Now what is that? How? Okay, so and when you're developing this smart meter, or when you're developing real-time operating system, okay, so all these features should be there. Okay, you have to keep it in a system. Okay, so you understood. So now how we will develop this particular RTOS for using say some kind of microcontroller. Okay, so using some kind of microcontroller, how can we develop? Okay, so what we are trying intention develop real-time operating system for smart meter. Okay, so this is basically high level of learning. Okay, so high level of learning, the cognitive level will be higher because this is basically uh, you know uh, comes under the evaluation or our creative level. So now how we develop, so this is one thing what we have to do. Okay, so how we have to start. So now the thing is, see, when you load any program in a microcontroller. Okay, so whatever the program you load, okay, so the main memory program will run. Okay, it is very simple, correct? So it will run. Now in that particular case, okay, in that particular case, what we have to do, so I'll try to, write some kind of program itself. I mean, like a C program. Okay, so now say for example, I may use you know what is that some microcontroller, maybe 8051 only, say. Okay, 8051 with external hardware connected. Okay, so now you see, uh, hash include. Okay, so maybe reach 51.h or 52.h, and int main. Then, okay, so I'm writing a simple C program. Okay, simple C program. Now you see here, in this particular part, what I'm doing. Okay, uh, say init uh, uh, resource, okay, management. Okay, some function. Okay, init. Okay, so memory management. Okay, so these are all, some functions I created. While this one, memory management, uh, this is scheduling, task management. Okay, so then interrupts. Interrupts. It is software interrupts. And then initialize init IO operations. I just written like this. This is basically initialization. Then what I'll do is just observe here, while say one. Okay, while one. Okay, so while one, or what I can say, uh, I'll just use some kind of uh, some kind of uh, so this one. So inside that, so I'll just have to, I don't know whether I can. I'm just taking that program. In it, and so then init, in place of init, I'll just write the resource management program. Okay, so then I'll stop the program. So in resource management, and then say I will write some kind of check time. So this function, I think checking this time, let that come inside that particular function itself. So now, so what is your comments on this program? What is your comment on this program? Can you see this program, and can anybody tell? Okay, so what is this program will look like, and so how this is connected to real-time operating system? Can anybody say? I just want some discussion on this. So now I told you I want to generate what is that? Uh, I want to make one operating system. Very simple. So now in that direction, how this program helps? Gnanadas, can you come online and could you please tell me? Can you see my program? I just written a simple program. Gnanadas, you're there? Your voice is not audible. Gnanadas, you're not there? Yeah. John, John, can you come online? John, you're not there? I'll just Iqbal, Iqbal, can you come online?
Yes, sir.
Yeah, could you please tell me what is the intention of writing this program? Can you understand this program, the pseudocode?
Yes, a little bit.
Yeah, please. You have to unmute yourself, Iqbal. You have to answer. Namita, Namita, can you come online? Namita,
Yes, sir.
can you see my program? What we are doing and what is the intention of writing this program?
So we are doing RTOS developing RTOS for smart meter using microcontroller.
Correct. That is the objective. So in this program, what is your observation or remarks? What is your comment on this program? I mean, whatever program I written, will you consider that as a RTOS? Can you see my program in the try to see carefully and could you please tell me?
Initial, it does make the basic requirements of RTOS.
Correct, correct. Now then, what is other? I mean, good observation. Any additional remarks?
No, sir. I'm not sure.
That's it. Okay, okay, fine. Yeah, Mohammed Yusuf, could you please come online and comment on this program? Yusuf, you are there? Yusuf, you are not there? Okay, come on. So Rupam, Rupam,
Yes, sir.
yeah, could you please tell me what is this program?
So this program is describing the all the design of an RTOS, sir.
Okay, okay. How?
Because each of the functions like resource, then the transient, and all these functions are inside the loop. So it will execute once every time. So eventually, it will do all the basic functions of an RTOS one by one.
Yes. That's all I wanted. Okay, good, very good, Rupam. That's a simple thing I wanted. Uh, Thank you, Rupam. Thank you. Good answer. Okay, so now you see there is something called in operating system round robin technique. Okay, round robin technique means it visits all the services one by one. You see. So this is a simple one kind of RTOS you can say. You can see some initial when you run this program, what happens? You see all the management functions. Management means it's a function, right? It's a program. All initializations are done. Okay, when you switch on the computer, all initialization is done. Maybe some specific state of all resource, memory, task, interrupt and IO operation should be there, that you are doing. Then immediately after that it goes to while loop, infinite loop. Then inside of that infinite, until your system is on, then all the function is executing one by one. Okay, one by one it is running. So that means all the resources function. Okay, so it is running. So inside this resource management, all other functions are there. You understood? So I'm just the overview of that particular RTOS I'm giving. So when you run this program, what happens? It look like RTOS. You understood? So now next question is we know the complex thing what they will do inside init resource management function. What are the things they have to do inside resource management? What they have to do inside memory management? What they have to do inside task management? What they have to do inside that interrupt function? What kind of sub functions they have to keep? You understood? So those are all. Say for example, IO operation, you may expect a keyboard should be connected. Okay, and you may expect some port should be connected, parallel port you may have, so that you may have to connect. Maybe serial port may be there, so that has to connect. Okay, so there will be some dedicated register which takes the data from that particular serial port, parallel port, and all. So now in this IO operation, all those things will be executed. All those things will be executed. All these functions will be executed. You see, one more thing, most important thing in this particular application, every function will have a timer, and time checking is done. Every function has a timer. So that means the timer will count the time, and if the initialization means they will set the time. So if the initialized time is crossed, then it will throw a failure message. It will immediately alert interrupt. It will execute and it will showcase. You understood? So in that way, if you want to start, if you want to write any RTOS, so this kind of skeleton you have to follow. Then later what you do for whatever functions you defined, keep on writing what is the content of that particular function. Okay, so just keep writing that. And I'm just showing this particular thing in C program, so that's why I written anonymous function. But actually in actual practice they'll use C++ program, where they'll use classes, and they'll create classes. Using classes they will create instances, Okay, so that what happens, a lot of advantages are there when you use classes and when you create a instances of that particular classes. So that is how they will do. So instead of this anonymous function, they will create classes for all these things, and everything will be object there. So that one modifications will be there in C++. Otherwise, if you're starting with simple 8051, and if you're keeping that in the system, so this is the structure what you have to follow. Okay, so RTOS, real-time operating system. See, a lot of things will come like LCD interfacing. Where LCD interfacing will come, IO operation. Okay, maybe some peripheral devices may be there. Resource management. Okay, so some memory restrictions, memory security you may have to provide. Okay, put it in the memory management. Some kind of lookup table is there, memory management. Okay, some kind of say, what I can say, some ADC is coming, DAC work is there, or some database tasks are there. Then comes under task management. Say some kind of if you want to keep some exception programs, then when some mathematical errors, okay, so are some syntax error, are some runtime error. Okay, what all those things will be kept in interrupt function. So now inside this each main function, you will be having hundreds of sub functions. So all those things, all the functions will be defined, and that you will call it as RTOS. Now in this you can see. Okay, so in IO operation, definitely when you are creating smart meter, in IO operation, voltage value, current value you are reading, that will come in IO operation. You see, voltage value, current value, instantaneous value you are reading, that values will come in IO operation. So IO operation, inside that IO operation, the voltage reading function will come, current reading function will come. Okay, so all this reading, real-time value reading, okay, functions are kept in IO operation. So in that way, I can say different modules are prepared. So that breakup of the entire, the complex task you will be doing in RTOS. Remember, it's not only executing function, also keeping track of the timer. Okay, so timer, they are, critically they will check every time. Okay, so that is one thing you just have to understand in RTOS. So this is basically RTOS program in a simple way. So you can take up in any form. But so now what is our, what should be our work? Our work is, so we have to develop RTOS for smart meter. Inside this main function, what are the sub function we have to create so that sub functions will be useful for smart meter? Can you see? Uh, you understood how we can create RTOS for smart meter. Now you understood the objective and the action plan. The action plan is that the functions, sub functions we have to create under each thing. Scheduling. What is scheduling? I may have to calculate energy. Okay, energy every 1 hour I may have to calculate and I have to display. Maybe time of use tariff may be there. So every 3 hours, different calculations I may have to do. Okay, so this kind of things, say for example, interrupt. If overcurrent comes, some protection you have included in the energy meter. So overcurrent comes. So some kind of exception program it has to execute. Okay, so some abnormal voltage comes, or some kind of things. So all those things basically comes under interrupt. So now with respect to the smart meter, so we just have to think about the function, and you may be having LCD display or some setting keyboard where that program should go. And if you have some kind of communication, internet communication or Wi-Fi communication, whatever, so where that program should come. So all these things you will carefully define in this main function. So related to smart meter. So then that will become RTOS specific to this particular application. So that is what I'm trying to tell. Now with this skeleton, I think we can implement the RTOS for smart meter. You understood what is how we can implement? So any questions on this? Any questions? Any questions? If you have, you can ask. If you have any question, please do ask. Yes, Ashwin, you are correct. It's packages. I'm just calling it as the function. Okay. Yes. I think your answer is correct. Expanded and theoretically do anything that is required. Yeah, absolutely, you are correct. So you see, that is what our intention. Okay, so and that's what whenever you read this RTOS, most of the people will give example like uh, flight management, or nuclear power plant. You see how critical fission reaction is there. Okay, so when you have to burn the fuel, and when you have to moderator, when you have to insert moderator, or when the DTO should circulate, and you see a lot of tasks are there, which is time critical. So if you want to implement RTOS for nuclear power plant, just imagine, okay, what should be the functions should present. Say for example, you are implementing robot. Okay, any robot. It may be a personal robot. It may be loading robot. It can be any robot, mobile robot, any robot. So how you can create sub function? Maybe balancing. Okay, or some visual input taking, or say giving some output in speaker. Okay, so all these things, and also some machine learning program, or some running some intelligence program in the back end, or simultaneously running some training program. You see, things, many things will come. Okay, so so all these things we just have to define, with respect to time space. That is very important. Time space is very important. Priority defined, how much priority this task is, priority is defined, time is defined. Okay, so that is basically the characteristic of RTOS. So that is how it is different from normal operating system. Yeah. Any question? Any question on RTOS? Please do ask some questions. Those who ask question, for them I'll give attendance. Ashwin, I'll give attendance. Mohammed, no. Rupam, I'll give attendance. Yeah. Iqbal, I'll give attendance. Others, please do ask questions and take attendance. Yeah, Rupam, I'll give attendance because you asked question. Na? So please others ask question and take attendance. Those who are asking question, I'm just writing their name. Yeah. So Sayak, IO management is basically you have a input output port for all the microcontroller. Okay, so even I told you na, not only direct input output operation. Normally, when you see any microcontroller or microprocessor, this is how they will follow. So this is microcontroller or microprocessor. So this is basically a number of ports. So this is basically IO device. Okay, one example is 8255. You can read. So this will it will have so many other port. So now how you can control this particular device? Okay, with some external world. So this is external. Maybe some sensor, digital input which is coming or going. Okay, so all this management will be part of IO management. Okay, so parallel and serial input output taking from the hardware is basically IO management. Is that clear? You can search 8255. You can understand better. Or direct port connection to external world. Okay, so Sayak asked question. Yeah, those who ask question, you can take a leave. Rupam, you can take a leave. Ashwin, you can take a leave. Iqbal, you can take a leave. Sayak, you can take a leave. Yeah, others, you can ask questions and you can take a leave from the class. Yeah. Vikram is asking, are there any pre-written libraries in RTOS that can be used for things like robotics? See, here, yeah, so I'll just tell you, see, microcontroller, okay, microcontroller or microprocessor. So I told you, you have a code memory, okay, code memory, and you have a data memory, okay, data plus user program, okay, user program. So any microcontroller, how this should work, how this microcontroller or microprocessor should work, everything is present in code memory. But how the robot should work, that should place in all those functions should be placed in user program. Okay, so code memory just keeps the how microcontroller or microprocessor should work. Your robot program or smart meter program or any RTOS program will be present in user program. Okay, so that is one thing. Okay, you got it, Vikram. There is no predefined, yeah, you can use it. You can use it if how microcontroller should work. If the same kind of thing you want, then you can use the code memory thing. But normally you can define all the things. Yeah, that is what Uh, okay, so Vikram is asking. So next, yeah, Mohammed Yusuf is asking, is it only C or can we use other programming languages? Yeah, see, now you can use C program, C plus plus program. You can see, no, Python program, Java program. You can see anything. Ultimately, you have to convert to xcode. Okay, so if any program gives embedded compiler, if you have a compiler to convert that to xcode, you can use any programming language. You have C++, C, Python, and Java. These are all widely used, and you can use not only C, Mohammed. Okay, so that is Yusuf question. Okay, so Gnanadas is asking how interrupt works in RTOS. Interrupt works in RTOS, I already told. So if any, say for example, divided by 0, okay. So somehow you made division operation 5 divided by 0. So Now immediately that is a interrupt. You understood? So that means some abnormalities, abnormal operation, uh, if it is there, then immediately there will be some lookup table. Okay, so lookup table or the function address. It will go to that particular function address and it will execute. So this interrupt we already discussed in microcontroller also. We called it as subroutine lookup table. Okay, and subroutine function. So any problem, it immediately it will go to the corresponding function and it will execute. It may be reset. It may be mathematical operation error, or it may be any hardware things, and here along with that critical time boundary also will be taken, and it goes to its interrupt is also a function. You have two types of interrupt. One is hardware interrupt and software interrupts. So hardware interrupts, anyway, hardware will take care. There are different priority interrupts will be there in microcontrollers, so that will take care. And there are a lot of software interrupts are defined. So it is basically the function. Okay. So that is what your interrupt words, Gnanadas. Yeah. So next, Gunashekar is asking how to make our own program for RTOS. That is what I am doing. Na? That smart meter, I'm writing my own program. So RTOS is nothing special. So I can write this program. I can develop all the functions. I can give it as a open source RTOS for energy smart meter. So that is our own program. RTOS should be you should have a main program and you should create all the functions, and all functions should be mapped to any one of the management. Very simple. Okay, all my functions will be considered as a system calls, like in operating system. Okay, so that is what you have to understand. So that is how I mean uh, you can create your own program, but instead of writing everything from zero, existing RTOS you can take and you can utilize. Okay, so that option is also there. But when you're implementing some application, try to write your own RTOS. Okay, so you can make it simply your main program is basically calling the management functions. Okay, so that is what Gunashekar is asking. Okay, Gunashekar, and can we write RTOS in Python? Definitely, I told you. You see, whatever high-level program you write, ultimately you require some compiler to convert to xcode, because only xcode will goes and it sits in the microcontroller. Most probably, we have a microcontroller module, okay, development board. One day I'll demonstrate how you can load the, how you can convert high-level program to Xcode, binary code, and how you can load that to microcontroller. That I'll demonstrate. But anyway, you need compiler. That's it. You can write it in any programming language. That is not a problem. So it just appropriately it has to convert to that particular embedded system platform. That's all. So the frequency should match and bits should match. Okay, all this, for that particular that microcontroller, your Xcode should match, because that Xcode should speak. I mean, it should work as per the code memory. The instruction present in code memory, as per that your Xcode should work, so that if no compatibility is there, then it won't work. So that's why you can write it in any way, but the only point is it should be compatible to the hardware. Okay, so that is how you should think, Namita. And Varshita is, can you give some application and where we can use the other than microcontroller? See, RTOS is specifically used for only embedded system. So it's basically on top of microcontroller microprocessor comes RTOS, and definitely you can use PLCs to create your own RTOS, PLCs, almost similar. So then, John, is it possible to code multiple platform? Yeah, I mean, if you have some kind of linkers where different modules, you are integrating and you are, creating, common output, okay, exe files, and then it's fine. Okay, so you can use multiple platform, but linkers should be there. And Gunashekar, how to make our program done? What is the difference between OS and RTOS? Yeah, please refer. OS is not time critical. Okay, RTOS is time critical. Okay, application. Time bound. Yeah, I already told Namita you can use in Python also you can use. Shoaib, how simple code will develop smart meter? It is not a simple. We it takes at least 1 year, 1 year, 2 year to make smart meter RTOS. I'm just writing some skeleton. That's it. It required 1 or 2 years to write this program. Memory allocation is more efficient in normal OS or RTOS. Definitely, time critical memory allocation and management is, should be effective in RTOS and limited. That is one thing what you can see in RTOS. Okay, so that means, it has to be fast. You have to keep and take it, with, within less time. So RTOS is different from OS. Yes. I mean, I told you many differences are there. RTOS and OS. Okay, so I already conveyed. Okay, sir, how do we add sub function in main function? Aniket is asking. It's basically, you can call some function in that main function. I am writing function. Inside that function, you can write a sub function, right? So that cannot be a problem. I told you, it is better to write a classes. Okay, so normally classes will be written. So it's basically writing a function inside a function. Okay, only you just have to define that function. That's it. In global scope or wherever applicable. What is the difference between OS and RTOS? Yeah, I told you, time bound without time bound. Yeah. Anybody missed question, asking question? Did I cleared all the questions? So Gunashekar answered, Abraham answered. Yeah, you can take those who gave answer, you can take a leave. Namita, Shoaib. Yeah, you can take a leave, Shoaib. I'm just giving attendance. Shoaib, Anujit, Amruta, Aniket, Abraham. Anybody missed? Anybody missed? Yeah, Varshita, you can take a leave. Next class, you just ask question. Huh? You not ask question. Yeah, Shreyans, Shreyans, you should ask question. Huh? Hari, again, you not ask question. Okay. Yeah, fine. Anybody? Anybody?
Sir, Pawan Kalan asked a question.
Where? What a question you asked, Pawan?
Sir, you wrote Harshita instead of Harshita, sir. My name.
Okay.
How to implement RTO projects in personal chat I sent to you.
Personal chat. What is personal? Where? How to implement that? I am not. Pawan, na? Okay. Pawan, I got it. I'll just explain in next class. Huh?
Okay, sir.
Yeah. So you can, Amrita,